A sample of gas occupies 17 milliliters at negative 112 degrees Celsius. What volume does the sample occupy at 70 degrees Celsius? So we know we have to convert the Celsius to Kelvin because that's what the T is. And so for this equation, we're going to use Charles' law because we are dealing with volume and temperature. So that equals V1 over T1 equals V2 over T2. Okay, so this is how we're going to find Kelvin. 273 plus whatever we're given for the initial Celsius. And that would be 161. And then for this one, 273 plus 70. 343. So these would both be our T's. This would be T2, and this would be our T1 in Charles' equation. Okay, so now let's set it up. So 17, no, that's 12. 17 divided by 161 equals, so we don't know what our initial volume is, so that's going to be our variable x divided by 343. Okay, so now we're going to solve for this. So 17 divided by 161 divided by 161. So that equals 0.1056. So that equals x divided by 343. Okay, so now in order to get x by itself, we're going to have to multiply both sides by 343. So this entire thing times 343. And then we're going to do this times 343. And then, so this will get us x, and so x equals 343 times 0.1056. So for that, we get 36.2208. And that is our final answer. So that is the missing volume. So that's milliliters. And that will be your final answer for this problem. A breathing mixture used by deep-sea divers contains helium, oxygen, and carbon dioxide. What is the partial pressure of oxygen at 101.4 kPa if pHe equals 82.5 kPa and pCO2 equals 0.4 kPa? So what we're trying to find is the partial pressure of oxygen. So that's going to be our variable x equals 82.5 plus 0.4. And so x, and so we're going to do that. That's going to be subtracted from 101.4 in order to get x, which is our partial pressure of oxygen. So 101.4, and then we're going to add what's in the parentheses together. So that will be 82.9. So all we're going to do to finish this equation is we're going to do 101.4 minus 82.9 to get our final answer, which will be our partial pressure of oxygen. And so x equals that will be 18.5. And that is our final answer for this equation.